The sun. It gives us life. Every day, it rises in the east, bringing light and warmth to our world. Without it, life as we know it would not exist. Plants rely on its rays for photosynthesis, animals depend on it to regulate their biological clocks, and humans bask in its glow for both physical and mental well-being. It bathes our planet in warmth, nurturing the ecosystems that sustain us. The gentle sunlight filtering through the leaves of trees, the golden hues of dawn and dusk, all these moments are gifts from our star. But you know, the sun is not always so benevolent. Its serene appearance can be deceiving. Behind its calm facade lies a turbulent and volatile nature. It has a fiery temper, capable of unleashing powerful storms of energy that can reach Earth. These solar flares and coronal mass ejections can send billions of tons of solar material hurtling through space at incredible speeds. These solar storms are a threat to our modern way of life. They can disrupt satellite communications, interfere with GPS systems, and even cause widespread power outages by overloading electrical grids. We must understand them and prepare for their fury. Scientists around the world are constantly monitoring the sun's activity, using advanced technology to predict and mitigate the effects of these solar storms. The sun is not a solid ball of fire. It's a complex and dynamic entity with layers that each play a crucial role in its behavior. It's a giant ball of plasma, a superheated state of matter where electrons are stripped from atoms, creating a soup of charged particles. This plasma is in constant motion, driven by the intense heat and pressure at the sun's core. Within this plasma, magnetic fields twist and turn. These magnetic fields are generated by the movement of the plasma and are responsible for much of the sun's activity. Sometimes these fields snap and reconnect, releasing tremendous energy in the process. This phenomenon, known as magnetic reconnection, is what triggers solar flares and other explosive events on the sun's surface. These events are the source of solar storms. Understanding them is crucial for protecting our technology and infrastructure from their potentially devastating effects. As we continue to study our angry star, we gain not only knowledge but also the tools to safeguard our future. Solar flares are like the sun's warning shots. These spectacular bursts of energy are a reminder of the sun's immense power and volatility. They occur when magnetic energy that has built up in the solar atmosphere is suddenly released. They are sudden bursts of energy, often associated with sunspots. Sunspots are cooler, darker areas on the sun's surface where magnetic fields are particularly strong. These magnetic fields can become twisted and tangled, leading to the explosive release of energy we see as solar flares. These flares release X-rays and ultraviolet radiation that travel at the speed of light. This radiation can reach Earth in just over 8 minutes, impacting our planet almost instantaneously. While powerful, they are not the most dangerous aspect of a solar storm. Solar flares are impressive, but they are just one part of the sun's complex and dynamic behavior. Think of them as the tremor before the earthquake. They are a precursor to more significant solar events that can have more profound effects on our planet. Solar flares can disrupt radio communications on Earth. This can affect everything from emergency services to aviation, causing temporary blackouts in high-frequency radio signals. They can interfere with satellites and GPS systems. This interference can lead to navigation errors and affect the functioning of various satellite-based technologies that we rely on daily. But their effects are usually short-lived, lasting minutes to hours. The immediate impact of a solar flare is intense but brief, allowing systems to recover relatively quickly. The real danger comes from the sun's heavier artillery coronal mass ejections. These massive bursts of solar wind and magnetic fields can cause geomagnetic storms, which have the potential to disrupt power grids, satellite operations, and even pose risks to astronauts in space. Coronal mass ejections, or CMEs, are the true danger. Imagine billions of tons of plasma blasted into space at millions of miles per hour. This is a CME. These massive eruptions carry the sun's magnetic field with them. If Earth is in the line of fire, the consequences can be severe. When a CME hits Earth, it interacts with our planet's magnetic field. This interaction can trigger intense geomagnetic storms. The effects can be felt on the ground, in the atmosphere, and even in space. Earth's magnetic field is our first line of defense against solar storms. This invisible shield deflects most of the sun's harmful radiation, protecting life on our planet. But a powerful CME can overwhelm our magnetic field, compressing it and creating geomagnetic storms. These storms can induce powerful currents in power grids, pipelines, and other long conductors. They can disrupt radio communications, GPS navigation, and even cause widespread blackouts. In our increasingly interconnected world, the consequences of a major geomagnetic storm could be catastrophic. Section 5. The Carrington Event, a glimpse into the abyss. In 1859, the world witnessed the power of the sun firsthand. It was a time when the mysteries of the cosmos were just beginning to be unraveled, and the skies held both wonder and terror. The Carrington Event, as it came to be known, was the largest solar storm ever recorded. Named after the British astronomer Richard Carrington, who first observed the solar flare, this event marked a significant moment in our understanding of solar activity. Telegraph systems worldwide went haywire, sparking fires and delivering electric shocks to operators. The technology of the time was rudimentary, yet it was enough to show the immense power of the sun's influence on Earth. Auroras, usually confined to polar regions, were seen as far south as Cuba and Hawaii. These spectacular light displays were both beautiful and eerie, a visual testament to the storm's reach. If a Carrington-level event were to occur today, the consequences would be far more severe. Our modern world is intricately connected through a web of technology that is far more vulnerable to solar storms. Our reliance on technology has grown exponentially since 1859. From smartphones to satellites, our daily lives and global infrastructure depend on the seamless operation of electronic systems. A similar storm could cripple power grids, disrupt communication networks, and cause trillions of dollars in damage. The economic impact would be unprecedented, affecting everything from banking to healthcare, transportation to communication. Today, scientists are working tirelessly to understand and predict solar storms. Advanced satellites and monitoring systems are in place to give us early warnings, but the challenge remains immense. Preparing for such an event involves not just scientific efforts, but also community resilience and individual preparedness. Understanding the potential impact and taking proactive measures can help mitigate the damage. The Carrington Event serves as a powerful reminder of our place in the universe and the need to respect the forces of nature. As we look to the future, we must balance our technological advancements with an awareness of the natural world. Section 6. The Digital Age, a world vulnerable to the sun. Our world runs on technology. We rely on satellites for communication, navigation, and Earth observation. Power grids deliver electricity to our homes and businesses. The internet connects us globally, but all of these systems are vulnerable to solar storms. A major solar storm could knock out satellites, causing widespread communication outages. Power grids could overload and fail, leaving millions without electricity. The internet, the backbone of our digital world, could be severely disrupted. The economic and societal impacts would be staggering. Section 7. Power grids at risk, a modern nightmare. Power grids are particularly vulnerable to solar storms. The long conductors that carry electricity can act like antennas, picking up the induced currents from geomagnetic storms. These currents can overload transformers, causing them to overheat and fail. A cascading failure of transformers could lead to widespread blackouts, potentially affecting millions of people. Restoring power after such an event would be a monumental task, taking weeks or even months. In the meantime, hospitals, water treatment plants, and other critical infrastructure would be without power. Section 8. GPS and communications lost in space. GPS satellites orbiting high above Earth are also susceptible to solar storms. The radiation from CMEs can damage satellite electronics and disrupt their signals. This could impact navigation systems used by aircraft, ships, and even our smartphones. Communication satellites are equally vulnerable. A solar storm could disrupt television broadcasts, internet connectivity, and mobile phone networks. In an increasingly interconnected world, such disruptions could have far-reaching consequences. Section 9. Predicting the storm. Scientists on the front line. Scientists are working tirelessly to better understand and predict solar storms. Spacecraft like NASA's Parker Solar Probe and the European Space Agency's Solar Orbiter are providing unprecedented insights into the sun's behavior. By studying the sun's magnetic field and activity, scientists can develop models to forecast solar storms. These forecasts can give us valuable time to prepare, potentially mitigating the worst effects of a major event. Section 10. Mitigating the threat. safeguarding our future. While we cannot prevent solar storms, we can take steps to mitigate their impact. Power grid operators can implement protective measures such as voltage regulation and load shedding to reduce the risk of blackouts. Satellite operators can harden their spacecraft against radiation and develop backup systems. And we can all prepare by having emergency kits, alternative communication methods, and a plan for extended power outages. Section 11 Conclusion. Respecting the power of the sun. The sun is a powerful force of nature capable of both sustaining and threatening life on Earth. Solar storms are a real and present danger to our technology-dependent world. But by understanding the risks, investing in research, and implementing mitigation strategies, we can protect our civilization from the sun's fury. We must respect the power of our star and learn to live with its occasional outbursts.